Hey the guinea pigs, I'm back to the lab. Today we will explore the RaSCSI. RaSCSI is a Raspberry Pi peripheral that can emulate in software a SCSI device. So first we will look at how to build one from the kit, and then we will see how to set up the software to emulate a hard drive and try it on the Macintosh Plus. So usually when I have a kit like this, I start by the lowest components. And here you see there are like 4 buffers that are like mounted surface components. So I will start with those. There is one gotcha here. If you look carefully, there is one of those buffers that is mounted upside down. So be careful when you build it up. For each component, I tack 2 pins on opposite corners, and then I go on with some flux and drag solder almost all the pins. Then we move on to a small pair of switches that activates the termination for the SCSI bus. So it's super useful that they added this feature, so you don't have to have an actual physical terminator to terminate your SCSI chain. Then the SMD USB connector. It's tricky. I had to actually fix it. I breached several times 2 pins there. It's very thin, so be careful. So now that the low components are soldered on, I moved on to the connectors. So first the SCSI connector. And finally, the connector that mounts onto the Raspberry Pi. I check quickly on a picture on the web to be sure that I'm not making a mistake. I also made the little extension to be able to daisy chain this device. So here I check if it fits well. And then finally, once I'm sure I'm all okay, I take some IPA and clean up all the flux I have all over the board. Alright, the device is ready. Please check with a microscope if you have one, if you didn't breach any pads, and especially the USB connector. So once it's ready, we can hook that up to the Raspberry Pi. Here I used a very old Raspberry Pi 2 And yeah, you'll see later that was not the best choice, but at least I had this one that was just gathering dust in my cupboard, so I used it. So I wanted to make like a kind of a permanent device because I can sacrifice this Raspberry Pi. So I looked in my stock if I can get like the good stands to mount it on the Raspberry Pi. And yeah, they are pretty standard PC stands. So yeah, I finally found 4 of the same kind and mounted them. There is something you need to know though. The standard screws for the PC are very tight. It actually works, but they are very they are mounted tight. So just force a little bit, but it should be fine. So here I do kind of a fitment test, and I've seen that the SCSI one internal connector has a kind of a little incompatibility with the Ethernet port. So I just took a blade and I removed like something like 1 millimeter, right? So the device is actually sits on the stands and not on the connector itself. So now that the hardware part is ready, let's move on and put the SD card and install an OS on it. So okay, now let's take care of the software part. So we can log into to our Raspberry Pi. What I did there is I installed Arch. I'm a kind of an Arch fan, so I just went on install Arch and install like all the basics for first like development, GCC and so on, and also Vim and all those things, and also looked at the dependencies from the projects from RaSCSI and installed them. And then let's clone the repo. Yeah, I'm not used to the Raspberry Pi. It is so slow. Come on, clone this little repo, please. Okay, got it. So in there, there is an easy install script that is useless because it's, for me at least, because it's a Ubuntu thing. So yeah, so I will inspire myself for it, but not really use it. To compile it, you have in the source directory, you have the Raspberry Pi directory. That should make your executable, right? So that's the first thing. Tries to find like compiler with a kind of a cross compiler, right? But I have GCC, right? It's there, right? So I think their makefile is kind of broken somewhere, right? Yeah. So you see, it tries to cross compile while I am on the machine itself, right? So that doesn't make sense. So let's not do it. So here you need to be patient a little bit. This is not a race car, this Raspberry Pi. Maybe I should have cross-compiled. Just checking if this thing is still running. Wow, that was slow. Oh, okay. So, what the hell is this? So it looks like it doesn't compile. Yeah, it looks like there is the error level is, that's a warning actually that doesn't compile. Okay, let's see if we can change that. Oh yeah, those. Those are the ones, right? Let's remove them. I don't know. Probably something is wrong in their CI/CD or something. And more wait for us. Okay, compile. It looks like. Where is it now? Where did he produce it? I'm sure. I don't know. Oh, there is a video over there. Okay. Full spec. Here we go. Looks like they are there. Alright, so apparently I can do like install. Oh, so let's go to the drug directory. Okay, doesn't look like it needs probably needs RaSCSI. So let's see how we do that on Arch. Simply install RaSCSI. Yes. Hopefully everything is compatible with Raspberry. Oh, it looks like I was missing something. Probably a dependency that did not set correctly on their side. Let's continue. Yeah, I choose the hard way with the Arch, right? Apparently this is maybe because pkg-conf is not installed. So let's see if that fixes it. So many things broken. Okay, so let's see. There is probably some sort of incompatibility in the file system. Okay. Does it do? Oh, it looks like it includes files from RaSCSI. Hopefully that will. Oh yeah, that works. Cool. Nice. Now let's try to start syslogd and this thing. Yes. Systemctl. log, so this one should work. Start it. Okay, has to go. Yeah, let's start this. See if it... Oh wow, cool. Yeah, nice. Looks like it runs. Amazing. Is it taking... Looks like it's running, it just doesn't use any resources right now. So, okay, let's be sure that it starts at boot. Alright, so now that we have the service running, we need to set up some kind of virtual devices on it, right? So the doc says that we can use the command RaSCSI. Okay, let's see if it works. Right. It looks like it responds. So let's create a hard drive somehow. So I don't know, here, I guess. Let's put that there. Say good. Oh god, this is slow. It's just 400 megabytes. Okay, finally. Wow, that was slow. Okay, let's try to... So now that we have an empty drive, let's try to tell RaSCSI to basically represent it on the SCSI bus. Didn't complain at all. Nice. Okay, cool. ID1. Nice. Let's try this and see if we connect that to the real Macintosh, if it sees something on ID1. Cool. So let's go to the bench. It found the device. It found the SCSI1 device. Okay. Let's try to initialize it. Oh yeah, we erased everything. Let's check how heavy it is on this small machine. Oh yeah, 95% CPU. So yeah, this thing is struggling to keep up with the accesses and so on. Oh, it's set up as a real-time priority, which is pretty cool too. Okay, let's wait for it to finish initializing the disk. So with my Macintosh, I have the 6.08 system disks, like original floppies. And after several tries, I realized like those floppies were corrupted, even though the Macintosh doesn't tell you it's corrupted. It just installed crap and just crashes at boot. So I looked for my grease whistle to try to recreate System 7 boot disks. The issue is that grease whistle software cannot make those. And but like a couple of days later, I realized that Flux Engine. So Flux Engine is another like kind of grease whistle device to make floppy disk. Flux Engine software can use the grease whistle hardware and make those Mac OS floppies. So that was my salvation. So I re-imaged like System 7 disk with this. So what I ended up doing is using my grease whistle, right, to write Mac floppies to be able to install System 7 on the Mac. But if you don't have a grease whistle to make your floppies, you can find on the web already made disk images, hard drive images, right? So, for example, this one. That works well. It boots straight from the RaSCSI. You put it, I don't know, like ID6, and you mount it with a script like I did here, right? And that works well. So it makes you like a bootable Mac. Then you can mount loop those drives, right, with Linux itself, and then you can copy files. So that's a way to do it. Still, you'll fight a little bit because you need a tool, right, to be able to write like floppy disk images or mount images of hard drives on your Macintosh itself, right? So there, what you can do is to make yourself a partition. So here I show the Mac Plus booting directly with an image of a 6.0.8 that I downloaded from the internet, and so that's your alternative to boot it up. I'll link up the file in the description below. So we are not done yet. If you looked carefully, I soldered on an I2C connector on top of the RaSCSI. So they have been cool enough to actually forward this I2C connector so you can connect a little screen. So let's see how to do this. Okay, so let's try out an I2C little screen like this, right? So check first there, right? It should be the same as there, right? So it works for me like this. Okay, so to make this OLED monitor work, it looks like there is a script called RaSCSI OLED monitor. So I'll try it. Okay. That doesn't look good. So this print statement, right, is from Python 2. Python 3, of course. So, okay, you know what? Let's try to make it work straight in Python 3. Oh god, this is really ugly. So yeah, probably will have like a lot of dependencies to fix. Okay, that looks good for Python 3 so far. Okay, it does stuff. Oh, it's really ugly, this thing. Oh, it's running straight the command, passing the output. Okay, so I think the library it needs now. So if I try to execute it, now it has a dependency error. I just fixed the indentation and like rough like Python 3 port. So it missed this one. And looking into the repo, I found this this package. So let's try to install this one. Hopefully that should make it work. Okay. Guess again. Oh wow, that's a lot of dependencies for this one. Hopefully everything will install. Okay, so I think this one we need to, because I see there, I see that we are using pill packages. Where is it? Yeah, there we go. We have pill packages. Yeah. Okay, so now we have an issue with I2C. It doesn't find the dev I2C one. Is it a lie or not? Oh no, really, we don't have I2C buses there. Interesting. Ah, okay, that means that I didn't. Actually, that's a command line parameter on the Raspberry Pi. So let's look at the. Okay, I'm unclear about which parameter we need. I'll try this one. So there we go. So I fixed the Python script to be compatible with Python 3. And you see that it says like ID6 is a hard drive and it's called empty.hda. Puts the date after that. So cool. So yeah, I have at least some feedback on the device itself. Yeah, so thank you. I hope you enjoyed this video. If you have any questions, feel free to leave a comment below. And please subscribe. So there will be other parts on this Macintosh. We are getting to the last stretch on this series. Thank you.